Hi guys, we're going to have a look at question 11. Now this is a graphing question which is really no different from any other question that we've done in calculus so far. Obviously these are exponential functions, so the first thing that you would probably do, and I've suggested to you to do when you're doing a graphing question, would be to go and graph it. So if you go to your y equals, and you can put those two functions in as you can see there, just remembering to use the negative button over here, not that negative. And when you graph that, you actually see those two functions come up there. So we're looking at intersect point over here, and we're looking at an intersect point over here. All right, so that's what you're going to do. It also gives you a bit of an idea about what you're expecting to see. This one obviously is going to a horizontal asymptote line there, and this one's going to a horizontal asymptote down the bottom. Right, so we've got to answer obviously the questions for this using that information. So in part A, the first thing that we have to do is we have to actually find the x and y intercepts. Now obviously the x-intercepts occur when the y value is equal to 0, and then the y-intercepts occur when the x values are 0. Alright, so you remember that from obviously probably year 8 or 9 or 10. So what we're going to say here is for our x-intercepts, let's do that first of all. So my x-intercepts are 1 minus equal to 0, so I'm going to have 0 is equal to e to the x take 3. Rearrange that, we've got 3 is equal to e to the x, so therefore x equals ln of 3. So that's my f function. My g function, I'm going to get 0 is equal to 3 take 5 e to the minus x. So therefore I'm going to now say that 5 e to the x minus x equals 3 e to the minus x equals 3 on 5. So that's there. Now I'm going to take the ln to both sides. Okay, so then that's going to give me minus x equals ln of 3/5, and that's minus x, so therefore x has to be equal to minus ln of 3/5. Now does that fit with my graph, keeping in mind x-intercept there, x-intercept there? I don't know if that's actually correct, is it? Right, so we'll have a look at that maybe in a second. Let's do the y-intercepts though. So y-intercept, so coming over here, we've got our y-intercept when x is equal to 0, so therefore our f of x is going to be equal to e to the 0 is 1, so 1 take 3 is going to give me minus 2. On this side over here it's going to be g of x, that's going to be equal to simply 3 take 5, which is going to be minus 2. So I've got those two values easily. So that obviously is one of the points where they're both cutting, isn't it, over there? So that's actually pretty important to understand that. The reason why that was a minus over there, just trying to go back to that. I'll have a look at that in a second. Right? I might explain to that in class. I just want to go through the rest of the question. It's not that important because I know that's wrong, and I'll do the algebra in a second. The second part of that is to discuss these functions as they go to infinity and minus infinity. Right? So the definition for this is part A, of course. So I've done that bit over here. Part B. So as x goes to infinity, right, we have to talk about what f of x does and what g of x does. Now, if we think about f of x is in fact equal to e to the x take 3. So as that happens, now the two types of functions that we've got here that we need to consider is we have e to the x, and e to the x is a function that goes something like this. Right? So it's always positive. And the other function we've got is e to the minus x, and e to the minus x goes like this. And that's always positive, isn't it? Okay, so, and we're talking about as we go to minus infinity, that's minus infinity, and as we go to positive infinity, what happens to these functions? So that's what we're going to be talking about. So as x goes to infinity, e to the x, that's going to get really big, isn't it? It's going to go off to being a big number. As minus e to the minus x goes to infinity, it's going to get to become a really, really small number. So that's what we need to understand, and then vice versa when we go off to negative infinity, and when we go off to negative infinity, then e is going to be a massive number. All right, so if that makes sense, then that's going to help us when we start to discuss this. So as that happens, we can say e to the x is going to go to infinity, isn't it? So therefore, f of x is going to go to infinity, isn't it? So here we've got g of x. G of x is going to be equal to 3 take 5 e to the minus x. So therefore, we're going to have e to the minus x is going to go to be, it's going to go to 0. So therefore, f of x is going to go to 3. Now, it's going to be a little bit less than 3 because it's going to be take 5 times by some small number. So therefore, that's going to go from below. All right, so it's going to go off to 3 from below. Now, as x goes to negative infinity, so therefore we've got our f of x is going to do what? Well, that's going to get really small. So therefore, what we're saying is, for that particular function, e to the x is going to go to 0. So therefore, f of x is going to go to minus 3. Now, because it's going to be a positive number, it's going to be a little bit bigger than negative 3, so it's going to go from negative 3 from above. Remembering, we've already graphed this, so we actually know what we're expecting to see. G of x, well, g of x is going to go to where? Well, g of x, that's going to become, well, the e to the minus x is actually going to go off to infinity, isn't it? So therefore, we've got 3 take 5 times by a massive number. So therefore, g of x is actually going to go to minus infinity. So it's going to be a massive number going off to negative infinity. Right, so then we've got to go to part C. Part C, we've actually got to find the points where they intersect. Alright, so they intersect obviously, and we do that algebraically, they intersect when e to the x take 3 is equal to 3 take 5 e to the minus x. Alright, so we can simply times everything by thinking, well, we can rearrange that first of all if we like. We could say e to the x, now that will be take 6, because the 3 is going to come over become minus, and that's going to be plus 5 e to the minus x is equal to 0. Now, the next thing that we do here is times this all by e to the x. Now, the reason why we do that is to cancel that e to the minus x out. So that will give us e to the 2x, take 6e to the x plus 5 is equal to 0. Most of these that you get are pretty easy to factorise. Remembering we have to treat that like a big X. E to the x, obviously 5 is 5 and 1. Because it's minus, both minus equals 0, which is good. That means that we'll have 2 points of intersection. So therefore, e to the x take 1 equals 0, or e to the x take 5 equals 0. So therefore that means that e to the x is equal to 1. E to the x equals 5. We know they've got to be both positive, so therefore x equals ln of 1, x equals ln of 5. We know ln of 1 is in fact equal to 0. Alright, so therefore x equals 0, x equals ln of 5. Now what we have to do is we have to find the y coordinates as well. we have to use one of these equations. Pick the easiest one. So the easiest equation to use in this particular case would be this one here. So we substitute both of them into there, remembering they have to have the same y coordinate as the same x coordinate, those 2 points. So therefore, if x equals, say, 0, then what we could say is our y value is equal to e to the 0 take 3. So when we do that, that's going to give me a value of 1 take 3 is minus 2. So that point there, so we should say if x equals 0, right? And so therefore the point that we've got there is 0, negative 2, which we found. If x equals ln of 5, then y is equal to e to the ln of 5 take 3. So that's going to give me simply 5 take 3, which is equal to 2. So therefore that point is going to be ln 5 and 2. Right, so we found the 2 intersect points. And then the next part of the question says you need to graph these. So if I'm graphing that, I need to put the intersection point there of 0, negative 2. And that point, intersection point there would be going to be ln of 5 and 2. I need to label which graph is which, and that's pretty well what I need to do with that scale. I think that scale of 5 to 5 is a pretty good one. So anyway, in those questions up to, I think it's 7, 8, 9, 10, you need to basically go through those steps. Now, remembering how Hazy works with his book, he teaches a lot of the skills at the start. This question here is putting a lot of those skills together in one question. Alright, so everything we've done in chapter 5 at this stage leads up to you being able to do these questions like question number 11. Alright, so good luck with those, and we'll talk about those in class.